So we have completed the solution. Before going to see the deformation and the stress result, let me tell you what ANSYS does in a background. So ANSYS basically solves this is given equation. K into U equals to P, right? So up till now you are familiar with this equation where K is a stiffness matrix, right? U is a deformation matrix. So it's very basic equation like K equals to P by U, which we solve. Now here we have another loading other than some external loads. That's a thermal load. So this thermal loads matrix is basically this E A alpha delta T, right? So you know that E alpha delta T is a stress into area is a force. So it's based on this equation. So ANSYS in the background solves K into U equals to P plus TH, this equations for each element. Now let's see the results. Let me rub this part which we have made extra. Okay, so let's find out the result of deformation, total deformation. Either you see total deformation or directional deformation in x direction, it will be same, because if there is only allowable expansion or a contraction in x direction, then I will see the beam result, like what is the axial force under this. There will be no bending moment because we are not applying any vertical load, only axial loads, only axial force will be there. Then I am interested in will go to the probe, and I want to see the different deformation at let me select this vertex. Okay, result only x-axis, so you can find out deformation from here. Then I will go to the toolbox and I want to see the beam tool. So under the beam tool, if we'll add a beam tool, we can find out direct stress and combined stresses. There will be no combined stresses because only the direct stress is present in this case. So let's right click and we'll say evaluate all results. So total deformation, what we are getting from this is 0.062 mm. If you want to see the 3D image, you can click on cross section and say thick shell and beams, so you can see the 3D. But this is just representation, because whatever the line deformations are there, it's just being visualized into the 3D. If you remember, there is only a 1D line which is being solved. This is just outer facial mask. Then these are the axial forces in each section. Let me probe this. I will go to result and will say probe. In this it is 20,803, in this it is 69,803, and in third it is 49,803. These are the stress result. In first section it is minus 20.83803, second it is 139.61, and last it is 166.01. So this way you can find out the total deformation, axial forces, and the other results. So up till now we have completed the ANSYS part. If you want to animate the deformation, you can definitely go, just drag up this, we'll go to the graph and we'll click on animation, so we can see how it is being deformed. So here it's fixed support, here it's fixed support, right? So our first verification step there, wherever we have provided the essential or fixed support, there the deformation should be 0, right? So it indicates 0 deformation here and here. So that's very first sanity check satisfaction happen, that at the essential boundary condition we are getting the result of 0, right? So that's first sanity check. Second, we also see that applied force and the reaction also we can find out. So for getting the reaction, I will just select this two fixed support and I will drag and drop to the solution, right? We'll say evaluate the result. In this case, it is basically statistically indeterminate because there is a thermal expansion also. So we cannot directly balance this force and check the result. That I will show you how to check the reaction in using hand calculation. I'm little right now hungry, so just you also take break, I'm also taking break. After the break, we'll see how to compare the result of answers with the hand calculation, which is very essential step of verification of results. Thank you.